Hello everybody, this is lecture 2 of electronic 1 course. The book is Electronic Devices by Floyd. My name is Amr Abdul Bari. I am the instructor of this course. Today we will speak about the diode circuits from chapter 2. So let's begin. Now the first circuit in diodes, as I speak last lecture, I discuss with you the physical phenomena or the physical underlying the diode, how it works. But now let's speak if we put it in a circuit, what is the behavior. Now let's see something called the rectifier. Rectifier is a circuit that converting from AC to DC. So it is one step in the conversion from AC, the current or the voltage, to DC voltage. So if we have, for example, this circuit, this is a half wave rectifier. We have here the AC source. We have here the diode, and here the load. This is our resistance. Now if the source have here it's plus and minus, so it is in this side, the current will go this side. Okay, now let's see the diode conduct during the positive half cycle. So the positive half cycle we will see plus minus, in the negative minus plus, so it's going transition from this side to this side as it's go up and down in the AC signal. So from T0 to T1, what's the behavior? As you see here, this is the input, V input. The diode connected after 0.7, it's connecting this and the voltage will flow as normal, and we will see at the output V output T0 T1. That's it. However, in the negative half cycle, so the minus here, positive here, so the current will go this side this time. But as we remember, the reverse, nothing will happen. There is no any current, so whatever the voltage, so there is no voltage here, so there is no voltage in the output here, so we will not see anything. We will see again this, we will see just 0. So this is what we know, that the half wave. So it just take the half wave of the circle of the input, and the other half it doesn't allow to allow the current to flow through the circuit. Now let's see what if the output of the diode is reversed. So the diode is go to the other side. So here the other side of the output, it goes we reverse the diode. Let's see what's happening. If you reverse the diode, you will get the other expected output. In the positive side, it will not conduct, so you will not see anything in the V output. In the negative side, so it will conduct like this, and it will the diode will operate, so you will see the negative side from T1 to T2. So you will see here the negative side. So this is the other half of the half wave rectifier. So if you put it in forward base, it will conduct the positive cycle of the V input. If you put it in reverse, it will conduct the other side, the negative cycle. So now let's see something else. We have here the peak inverse voltage, like something we definition is equal to the peak input voltage, and is the maximum voltage across the diode when it's conducting. So there is a maximum voltage across the diode when it's conducting a voltage. So Here V input, it's like this. So what is the maximum voltage across the diode when it's not conducting? So when it's not conducting, there is a voltage across the diode, but there is no current, so it doesn't, the R will not see anything like a cut here. Okay, so this is the definition of peak inverse voltage. Now here, this is in the other side if it is in forward base. So let's see if we see here it's by applying, yes, here he specified by applying the Kirchhoff voltage law. The load voltage is 0, so the input, all of the input voltage across the diode at TB. Okay, the highest or the peak voltage. Okay, now the center tapped, I want to make a full rectifier now. A center tapped transformer is used with two diodes. So I put two diodes, so they want the two sides of the circuit. Now a center tapped transformer here, we put the ground here from the centers. That's why it's called center tap. So when the input on both of the diodes are connected in the forward base, and then the RL. Now when in the positive half cycle, here in the positive half cycle, it will go from here plus minus. This is the signs of this center tap transformer. So the flow of the current, which is we are about, is going for this side. So this one, this device D1, diode D1, will conduct, and all of the half cycle will go to the load. However, the other one, if it is go like this, this is will be minus, so it will not conduct. So in the first positive half cycle, it will, the D1 will conduct, and the current will flow through D1. However, D2, it will be in a reverse bias. Okay, now let's see, this is in the second or negative half cycle. You see that the signs of the transformer is changed, reversed. So instead of positive minus, it's minus positive. Here the current will go through the second diode D2, so it will conduct the second the negative cycle, half cycle. So as you see here in the total output, if you test the voltage across the RL, you will see that you take the positive half cycle and the negative half cycle. This is the meaning of the rectifier. I am trying to rectify the AC voltage until I achieve a DC, a small line. Okay, now if you analyze the circuit, you will see that here, if when this is D1 is the conducting and D2 is reverse bias, if you apply a Kirchhoff voltage, you will see that there is a peak inverse voltage can be shown here across this diode. From this point to this point, there is the peak inverse voltage over 2. Okay, now notice that 1/2 of the peak secondary voltage will be across the reverse bias diode. I want to ask a question now. Why it's VB? As we said before, it is the total, the highest voltage of the cycle. Why it's now here it's VB over 2? This is a question for you to search and solve. Now there is another circle that we use as a rectifier. This circle we call it the bridge full wave rectifier. The bridge full wave rectifier used here, as you see here, 4 diodes. You see here 4 diodes connected like a bridge here, and connected to the same transformer, but here without a center tap. It's not a center tap. Here it's a full transformer from the two sides of the transformer, and this is in the secondary side of the transformer. Of course, this is the primary side. We name it this. In the left side, this is the primary side, which connected directly to the source, and the secondary side is the circuit of the rectifier. Now here, if you analyze your circuit in the positive half cycle, you will see that the voltage plus minus, so the current will go through like this. As you see, this is the BN junction, so this is will go through the circuit without this diode D1 without any problem. Also, because this is in the circuit, the current will go from here. You see, this is the flow of the current. This one also will conduct. So I have now if you see here, this is two ground, but in reality all the ground are one point, one connection. So this is a closed circuit. So the current will flow like this, flow from here, from the start here, as you see here in the red line, and this diode is in forward bias, so it will conduct, and this diode it will conduct. So you will see in the output a full positive half cycle. In the other side, in the negative half cycle, you will reverse the sign of the transformer, and then the current will go through D3 and D4 until you see it on the load. So you see two half cycle in the load. This is the bridge full wave, another circuit, because we here see the circuit for two diodes. Here we see a circuit for full wave rectifier with 4 diodes. Okay, now the question is, what is the peak inverse voltage equal to? It should be equal to the V output, because I think this is the second question for you. Here this is the 4 diodes, and should be the voltage inverse voltage. The peak inverse voltage should be across 2 diodes that not conduct, that is in reverse. So why it's not VP over 2 or VB? So why it's equal to VB? This is the second question. Now let's see here the equation, an example. Determine the peak output voltage and the current in the load. Here the load 3.3 kilo ohm, and the voltage V secondary. This is the V secondary RMS. It's equal to 24. So use the practical diode model. So the peak voltage here, this is the equation to take the voltage from the VRMS. So the voltage RMS multiplied by 1.41 or the square root of 2. It is the V peak, which we take here in the positive half cycle and the negative half cycle. Now let's see here. What I can see at the output is the voltage, the VB out equal to VB secondary. This is the VB secondary, that's here from this point to this point, minus 0.7 for diode, because it's come from this side to this side. Yes, here as you see. So it's minus 0.7 for D2 and 0.7 for D1. So it's 1.4. So just a subtraction from the value here, you will take 3.2.5. This is the output of the voltage. Okay, Now apply the Ohm law, you can get the voltage, the current. The current is equal to voltage over the load 3.3 kilo ohm. So you can easily get the current that come across all this circuit. Okay, now let's see another thing. As you see here, I speak about converting from the AC voltage to the DC. However, as you remember, the DC it's like this. It's line, not like half circle or half a cycle, not like this. So we need something that's smoothing this these ripples or these tops, to convert it to one line. Now we will see this in the circuit. Now this circuit we call, if we filtering is the process of smoothing the ripples from the rectifier, as you see here. So it's supposed to be like this from the rectifier, and you use something to remove these ripples. We call it the filtering. You use a filter to convert it to a DC. What is the filter here? We use a circuit, an easy circuit, a small circuit. We use a capacitor. A capacitor before here conducted in parallel to the R load. So this capacitor is widely used. It's half wave rectifier here and the capacitor input filter. So the capacitor do what? Here the other half, which is off because the diode will be in the reverse bias. But here what's happening is this, when it conducting in the first, this the voltage, the current, sorry, will go through this capacitor. So the capacitor will charge until the peak, so in the half cycle it begin to discharge the charge that take it from the first half cycle. So the discharging, it's this line. It should be achieve zero, but at long time, and then the half cycle, the positive half cycle come again. So it's return to charge and then recharge, discharge, charge, discharge. So that is making this shape. Okay, now how is the ripple affected by the RC time constant? The RC circle here affecting the ripples by making longer time or shorter time. Okay, so we need to that this charge of the circle here, this charge of the capacitor, we need it to be long time. So if it is like this, long time to discharge, it will achieve the time until there is the next half cycle, and the ripples will be very small. So it is approximately line. Okay, now let's see another circle, a power supply. This is the circuits in the power supply, that you see it in the charger of your laptop or the TV or the fridge. Any device now have a power supply unit that converting from the AC that's coming from the electricity company and converted to an DC that is rectified and at the demands of this device. For example, some devices want 5 voltage, DC voltage, or 4 or 12 or 24. So this is the basics of the power supply. that we almost used everywhere around us. So the voltage regulator here, this is the last step. The voltage regulator can furnish a constant output with excellent ripple rejection. So it just here after the rectifier, after the full wave rectifier, you will see a circle like this. You will see these cycles. Imagine that you have a capacitor that this is charged, then there is another capacitor that this is charged, then the capacitor, a capacitor. It's like this. So imagine that you have 10 of this one, so your line will be like almost approximately like this. It should be in a line or approximately a line that is the DC voltage that we want to generate, or we want to convert from the AC source. Okay, so the external capacitor completes the regulation portion of the circuit. So the regulator make it more smooth. Okay. Now let's have some definitions. Line regulation. This line regulation meaning the output voltage over the input voltage. It's a percentage of the output voltage to the input voltage. So it specify how much DC you take or change, how much DC it change if there is a change in the regulator input voltage. Okay, so it's based on the DC input voltage change to the regulator. So it's due to the change in the AC line voltage. Okay, so it is measuring how much regulation, line regulation if you have. So if we have a question here, we have a change by 1 voltage due to the AC line, and now the output should change by 1.5 millivoltage due to this change. So the line regulation, very easy, you just divide 1.5 millimeter over 1, so it is 0.15. so this percentage is like you check if this is a smooth line or there is some changes in the line. It's not shown because this is very small percentage, but there is a change. Okay, load regulation specify how much change occur in the output voltage for the change in of the load current values from no load to full load. No load means there is no if you see all the circuits that I give to you here, there is this is the load here. This is should be no load. If we have a load here, should be there is a resistance here. We refer to any load in our system as equivalent resistance. Okay, now here the load regulation is the voltage with no load minus the voltage with full load over the voltage with full load. So the question will be, as the change in the DC change it from 5 with no load to 4.96 with full load, and what is the load regulation? So the load regulation, it's like this: 5 minus 4.96 over 4.96 multiplied by 100. So it's again a percentage, 0.8. So another circuit, the diode limiting. Diode limiting, it's a circuit of diodes that limit or cut the some of the input. So it make like a threshold here. If the voltage higher than this voltage, it make a limitation, so it give you output like this. So here he make a summation that RL should be higher, very large than R1 to avoid loading effect. So here the voltage will come across R1 and come across the diode. Okay, here the diode will conduct after 0.7, and there is, we make a conducting here another source, but this is AC source, this is DC source. So DC source, it is in the positive side, so positive negative positive negative, so the summation here will be V bias plus 0.7. this is the cutoff voltage. I don't want any further voltage. For example, this is a limiting circuit. Okay, what if we reverse it? Now we take some example before the reverse bias. So the example here will give you 0.7 plus 2.3, so the limit is 3, so anything that go above 3 will be cut off. Okay, so limit to less than 3 voltage. Now this is in the circuit, oscillator. So what happened in the previous circuit if we reverse here? This is the reverse of the diode only, so the diode only reverse side. So we will see a cutoff from the other side. Okay, so from the other side here, so a minus. So instead of 0.7 plus 2.3, the current will go this side. Okay, this is the reverse side, so it will not cut off anything, but it will cut off from the other side, from here, in the reverse bias. So it will cut off when it go through in the negative half cycle. But what is the value? The value here, it is here it is minus, here it positive, here it is minus. So 0.7, 2.3 minus 0.7, it should be 1.6. This is the cutoff. So it is not only in the half the negative half cycle of the input, it is in the positive side. So this is the line that everything below will be cutted, and only the positive half cycle will go through the cycle, go through the circuit. Okay, above 1.7. Okay, now a clamper or DC restorer is a circuit that add a DC voltage. So if you see in the devices in the lab, we can change the DC, we can add it a DC to the AC. So instead of the origin around go up and down around the 0 voltage here, it should be like this, it go up. How we can edit this? We can edit it using the circuit clamper. So this circuit we just add here as a capacitor. The capacitor here, it charge the cycle, in the cycle minus the voltage across the diode. So the voltage across the diode is 0.7. So the voltage that come up in the V output, it will be VBN, the V input, minus 0.7. This is the point, this point. So what's happening if we reverse both of them? It will go down. It will go down V minus V input plus 0.7. So this, because this is plus here and this is negative. So this is the negative side of the input. So it will go down in this side, and here you see above the 0 line by plus 0.7. Okay, now another circuit, voltage multiplier using the clamping action to increase the peak rectifier. So if you see here a circuit, here the input, here the transformer, we take it from this side and this side, the full transformer load, and we put two reversed diodes. So one will conduct in the forward in the positive half cycle, and the other one will be reverse biased, and one will be the D2 will conduct through the negative half cycle, and the D1 will be reverse biased. Okay, now D1 in the positive half cycle will charge the capacitor C1, okay, in the positive half cycle, and in the negative half cycle D2 will charge C2, the second capacitor. Okay, now if you take the here from here to here, if you take the output from the over that's two capacitors, you will see double the V peak, double the V peak. That's why it's a voltage multiplier. It's used, if you see here V with the V peak, all the V peak it charged in the C1, and all the V peak in the negative side it charged in C2. So you see in both of them the double the voltage that's in the input. Okay, now the diode data sheet, usually if you buy a diode from any electronic device store, you should know the number of this diode and search for the data sheet. Okay, because the data sheet give you some information about the temperature, the voltage, the current, and other important parameters. Okay, so I will leave this for you to read and have information about it. Now today we speak about the rectifier, which is an electronic circuit that convert AC to DC, one part of a power supply, the filter in the power supply, the capacitor used to reduce the variation of the output from the rectifier, it's removing the ripples. A regulator circuit, it's the maintaining the essentially constant output for a range of input voltage. So if you have an input voltage, a range of input voltage, it's giving you a constant output whatever the input. We didn't take what is inside the regulator today, but this is to inform you about the power supply, all the circuits in the power supply. What is a ripple voltage? The ripple voltage is the small variation in the top of the output of the full wave rectifier or the rectifier, so caused by charging and discharging of the capacitor. Okay, a line regulation is the change in the output voltage of the regulator for a given change in the input voltage, so expressed in a percentage. The load regulation, the change in the output of the regulator for a given range of load current, normally expressed in as a percentage. The limiter circuit, it's a circuit that clip off or remove part of the wave according to a specified level. The clamper is a circuit that add a DC level to the AC, even to up to the positive voltage or down to the negative voltage. It depends on how you connect the diode and the capacitor. Okay, thank you for listening. This is the end of the lecture.